So now we have a 6x6 grid, and Adela, I'm going to turn away. Adela's going to flip one of those cards over. Tell me when you're done.
I'm done.
And now I'm going to be able to decipher which one it was. Okay. I'm looking. It was this one right here.
You are correct.
Woohoo! Fantastic! My name's Danelle Hogan, and I'm the director of the STAMazing project here at the Pima County School Superintendent's Office. First, I'm going to show you a physics trick. Here's a welded ring and a lamp pull chain, and if you bring this ring up like this and drop the ring and say, physics, it looks really cool, and some people might mistake that for magic, but in my world, there's no such thing as magic, only physics, which does not make the world less awesome, just more interesting. Today, we're going to learn a math-based magic trick. It comes from CS Unplugged, a really awesome website that shows really cool ways to do coding offline. And then we're going to take that trick one step further and show you how you can code secret messages back and forth to your family and friends. All right, to do this trick, you're going to need some cardboard pieces that are cut out of food packaging boxes. So cereal boxes work really well where there's printing on one side and cardboard on the other. Once you have those cut out, you're going to have somebody who's doing this trick with you lay out 25 cards in a 5x5 grid is shown. They don't have to do it on this fancy grid pattern, but it'll be easier for me to explain a few things if we use it. That after they've laid out their cards in a 5x5 grid, then you're going to add what we call the parity bits. So this would be the data that one computer is sending to another. And then on the outside edge, we add an extra column and an extra row, and we make sure that they are laid out in a very specific way. So if you're doing this and pretending it's a magic trick, then you can pretend that you're adding an extra column and row to make it even harder, because now there'll be 36 cards. But in fact, this is what is allowing you to do the trick itself. So what we have to be sure of is that the number of cardboard sides up and the number of print sides up are even, an even number, like 0, which isn't really odd or even, but we'll count it as even, 2, 4, 6, sides up or sides down in each row. So in this case, we have 4 cardboards already, so I'm going to have to put this print side up. So there's 4 cardboard sides and 2 print sides. In the next row, it's going to have to be cardboard side up because we have 4 print sides up and now we want 2 cardboard sides up. In this case, we want to be careful that even doesn't mean 3 and 3, but again, it's an even number. So we have 2 print sides. We want to make sure that we have 4 cardboard sides. So there's 2 printed and now 4 cardboard. In the next one, we have 2 cardboard. So we want this to be print side so that it's 4 print side up. In the next one, we have 3 cardboard. So this is going to have to be cardboard to make that 4 and 2. And then now we can start on this bottom corner. We have 2 printed. So we want 4 cardboard and 2 printed. This will also be 4 cardboard and 2 printed. Here we need a printed side because we already have 2 cardboards, which is even. Here we're going to have cardboard. In the next one, printed. And this final one should actually make sure that serve as a check for each of these rows and the row and column that you just added. And so this should be cardboard side, which will make it 4 and 2 this way, and also 4 cardboard and 2 printed that way. So now we've set up our cards for the trick. At this point, you can look away from the grid itself and have somebody turn over any one of these cards that they want, and you're going to be able to look back and immediately pick out which one it is. So let's say you looked away and somebody turned over this card right here. So they flip over this card right here, and you look back at the grid and you're trying to figure out where the error is in this data. Well, all you need to do is start going column by column and say, all right, these are still even, 4 and 2. This is still even, 4 and 2. Oh, this has an error in it because it only has 1 cardboard and 5 printed. So I know this is the column that the error is in. And then you can start here and start saying, all right, that's still even and even. 2 and 4 here, 2 and 4 here. This one has an odd number. It has 5 printed and 1 that's cardboard. So where that row and this column intersect, that is where the error is in the data. And that's how computers, when they're sending data, will be able to double check and make sure if there's an error in the message that's been sent, and then they can correct it. So that's where the CS Unplugged lesson would end, doing that trick and having it where you can pick out which one that somebody flipped over when you looked away, which is really fun, but it turns out you actually can send a message using these cards. And I have in fact coded a message in the cards here. So what I've done to code that message is I've used what's called ASCII, the American Standard Code for Information Interchange. The most common way to send messages back and forth and code for the alphabet and a few more characters is the ASCII codes. And so with zeros and ones, I can represent the whole alphabet and a bit more. So using the ASCII codes in this 5x5 section that we did originally, I coded a message. So each row in this case represents a letter. And to decode this message, all we have to do is convert it to zeros and ones, where the cardboard is going to stand for a 0 and the print side is going to stand for a 1. If you want, you can also print out 0 and 1 cards, and instead of doing this with the cards that you've cut out from a cereal box, you could actually do it using cards that have zeros and ones on them. For younger kids, that might be a good way to go because it's a little bit more concrete. But if we say that the cardboard sides are zeros and the printed sides are ones, then all we have to do to decode this is look at what those 5 numbers are. So this is 0, 1, 0, 0, 0. On our list here, if we look for that code, 0, 1, 0, 0, 0, that first letter is an H. The next letter would be 0, 1, 1, 1, 1, 1. And so 0, 1, 1, 1, 1 is O. And so on and so forth. You can continue on and decode the word that I have embedded in this pattern. Now it's time to take our message coding to the next level. Here's a 7x7 block that has 7 letters coded in it using the 7-bit ASCII alphabet. The next step, once we have our 7x7 code out, is to put our error detection column and row around this. So I'm going to do that now. And this works just like the 5x5 did before. So if I'm looking at ones or zeros, they need to be even. So in this first row, I have 2 ones, and now I have 1, 2, 3, 4, 5, 6 zeros. So that's even. 3 ones, and so I need this one to be 4 ones and 4 zeros. In the next one, I have 2 zeros, so I know this has to be a 1 to get 6 ones. I have 2 zeros in the next one, so I know this has to be a 1 to get 6 ones and make the ones even and the zeros even. In the next row, I know that I need to put this one this way, so we have 4 zeros and 4 ones. In the next one, it also needs to be a 0. Whoops. And in the next one, it needs to be a 1. Then we need to go along the bottom row just like we did before. So starting down here, all ones, so this one has to be a 1 as well. In the next one, there's 1 0 at the top, so this one's going to have to be a 0, so there's 2 zeros. In the next one, I need it to be a 0, so we'll have 4 zeros and 4 ones. In the next column, I need it to be a 1, so it's 4 and 4. In the next column, I need it to be a 0 because they're all zeros. In the next one, a 1, so it's 4 and 4. In the next one, a 1, so it's 6 ones and 2 zeros. And in the final column, it's going to be a 0, so it's 4 and 4 this way, and 4 and 4 this way. So now we're done, and we have our error detection and correction data around our data block that has our secret message. If we wanted to, we could also send people an error that they have to decode. So we could do this and flip this one over to a 1. In that case, when somebody's decoding this message on the other side, the first thing they're going to have to do is exactly what we did before for error detection and correction. They'll have to go by each column and figure out, oh my gosh, this one has an odd number of zeros and ones, so somewhere in this column there is an error. And then they have to go row by row until they find the one that has the odd number here. And then wherever those intersect is where the error is, so you'll have to correct that first by flipping this back over. And now, using your ASCII code cheat sheet, you can decode what these letters are in this block right here and determine what the word is that I've embedded in this data block.